In this video we are going to talk about insertion sort. So today we are going to learn about the insertion sort. So let's suppose that we are given an array and we get it sorted in increasing order. Whenever we are given any array, we have to sort it in increasing order. So here is what we are going to do. Like whenever we are doing insertion sort, what are the basic things we do? And as I'm explaining again that these videos are going to give you the basic idea of the sorts, not the coding concept of the sort, but actually how do they work. Once you understand the basic concept, how do they work, then you can implement them using the pseudocode and all that related stuff. So first of all, what we do when we talk about the insertion sort, we will start from the left and work to the right. Like we will start from the left items, the items on the left side of the array. We will sort them out and we will work to the right, and finally we will have a sorted array, and you will understand with the coming visuals in the video. We examine each item and compare it to the items on the left. We start with from the left side and compare the items which are on the left side and insert the item in correct position in the array once it's sorted and once we get that it's not in the correct position. So you will notice that the part of the array will get sorted as we progress. So the array will form the sorted and unsorted partitions. And to distinguish that, we will color the sorted partitions as green, so you will know which partitions are sorted. So let us begin and see what I mean. Let's consider that this is our array 285394 and we want to sort it out using insertion sort. First of all, we will start with the 2. Now you can see that 2 is actually the smallest number, so we do not need any swapping with any of these. And another thing is that it is the leftmost number or item already, so there is nothing on the left of the 2, so that is why we cannot swap it or compare it with anything else. So it's already sorted, we color it green. Next we see that we have item 8. Now you can see that if I compare the item 8 with 2 is smaller, 8 is larger, that is why 8 is in the right position, so I just color it green, and then I move to the next item, that is 5. Now you can see that 5 is to be compared with the items on the left, so if I compare it with the 2, 5 is larger or greater. If I compare it with the 8, yes, they are in wrong positions. 5 needs to be inserted before 8, so that is why 5 is going to be inserted after 2 and before 8, so that is why it needs to be inserted right here. So we swap the 8 and insert the 5 right in this position. So now we can see that our 3 items are being sorted, 2, 5, 8. The left items are sorted and these are not sorted ones. We next compare the 3. Now you can see 3 is to be compared with all these. It is not greater than 2, then leave it, but it is greater than 2, that is why we leave it, but it is smaller than 5 and 8, that is why 3 has to be inserted at this place. That is why we will swap the 3 with 8 and 5. First of all, 3 will be swapped with 8 and then it will be swapped with 5, and here 3 is inserted after 2. Now you can see our 4 items are being sorted. Next we compare the item 9, and here you can see that 9 is greater than all of these items, that is why 9 will stay where it is. Then we have our last item, that is 4. 4 is to be compared with all of these items, not with 2 and 3, but 5, 8 and 9 are greater than 4. That is why 4 needs to be inserted after 2 and 3, right at the position where the arrow is directing. So we will swap the 4 one by one with all of them, 9, then 8, then 5, and finally the 4 takes its place. And here we can see that our whole array is being sorted. So that's it, we are done. Insertion sort is one of the most straightforward sorting algorithms, and you can see that it did the work very nicely. Here is the pseudocode for the insertion sort. You can see that we have a for loop and a while loop, and that's it. In insertion sort we have big O and square comparison and swap. So why this happens? Because let's think that it means that when you have an array in decreasing order, you need to compare and swap every item. That means that both loops will work, because whenever we have two loops we have n square complexity, and where n is the number of items in the array. So I hope you understand this concept very nicely. So if you have any questions, please tell me. Thank you very much. Please give your